Today I decided to see if I could just get basically anything, any kind of current going through um, the pipettes that I pulled yesterday. Um, I'm not really trying to do anything sensible. Just have a go basically and see if I can get anything working. And I think I fulfilled my goal of seeing that I could get like a current that varies with the voltage. It's not a particularly ambitious goal, I don't think, but that's the idea. So basically, we have a solution here, which is kind of the ionic solution, ionic buffer solution, whatever, which is KCl, and it's about 100 millimolar, I think. I diluted it to something like that, and then I have this is a Axopatch 200A. So this is kind of an older model, which is the model before the 200B. I picked it up on eBay, and I picked up the unit and the head stage separately. I don't think it's particularly well calibrated. You know, there should be a calibration procedure on the to match the head stage to the unit, and I kind of did some basic calibration using a like a mega 100 meg and giga ohm resistors, but I don't think it's particularly well calibrated. So the whole bunch there's lots of issues, I'm sure. I didn't have the right tubing to go from here, to go from the patch clamp to the syringe. So this is a bit of silicon tubing for some wire. I pulled off a piece of wire, so it's all very just bodged together, and obviously the solution is just sitting in a cap. So basically what happens is a voltage gets put across this solution. So this is the ground terminal that's coming in, this red wire, confusingly, that is going just into the bath, they call it, into the solution. And then the micropipette is sitting in that solution as well. And you pull up some of the solution into the pipette, you pull it up with the syringe, and it makes contact with this silver wire, which is I believe it's a chlorinated silver wire, and I'm just using the silver wire that was in there when I bought. It's actually from another rig, but it was just in the holder thingy when I bought it. So I poured up some of the solution into there, and then turned on the patch clamp, and it's connected to a scope. So on the scope, if I can move things around, here's the scope. I guess obviously there's mains hum, but basically if I vary the applied voltage, and I think this is 0. Or yeah, there's an I think there's an offset on it. So I think this may be like a negative voltage. So I'm just kind of playing around with it, see what I can see on there's a readout on the thing which says this is like -2 nanoamps, but I don't really believe it, I don't think. But yeah, let's go to 2. Okay, so this is 2 turns of the holding command, which I believe is the applied bias voltage. So this should be 40 millivolts, and then if I give it another turn, this should be 50 millivolts. So 40, 50, which is then going almost across the full range. But yeah, it's kind of working. So I still can't characterize the tip size from that. It's way too messy an experiment. Um, but fundamentally, I think I have a little bit of confidence that this rig can work, and I have an aperture at least in the capillary, which was something I was also worried about. I was worried if the puller, is there's something wrong with it, and the pipette tip is completely kind of occluded, or stuff like that. So it does seem like there's an aperture there. So that's just a first go. I have another Axpatch 200B, so I might try the 200B. I think I need to work out. I need to get the current measurements in calibration. So I have so that what's being shown on the scope is the current that's flowing through. So so this instrument measures the nanoamp level kind of current that's going across going through the ionic flow, and sticks out a voltage. And I have the current to voltage relationship is not well calibrated, so I'll need to figure that out. Yeah. Anyway, first test. So I figured it would be useful to kind of document that at this stage.